Hey everybody, Dr. A here, and in this video we're going to be discussing a little bit more on beam columns. Now, for my purposes, I'm going to be talking, in a sense of steel beam columns, but these concepts can be applied to pretty much any kind of beam column, whether it's steel, concrete, wood, whatever. But again, I'm going to be talking about it mostly in the setting of a steel beam column. So in general, beam columns are typically components of frame systems. And what I mean by that is you typically don't have a single member that is a beam column just kind of existing as one member, and that's it. Normally, when we see beam columns, they're an element or a component of a more complicated frame system, okay? So depending on external restraints of your frame system, your frame could or could not experience what we call side sway. So we're going to say depending on constraints, a frame may or may not experience what's called side sway. Okay. And a little more specifically, we can have the following: a frame may be braced against side sway. And in some cases, in some rare cases, you could have a frame not braced against side sway, may not actually experience side sway depending on the applied loads. Okay, so you could have a frame that's not braced against side sway, and that means that it could experience side sway because it's not braced against it, but because of the nature of the applied loads, it won't actually experience side sway. So you have kind of two topics here. You've got a frame that's braced against side sway versus not braced against side sway, but then you also have frames that experience side sway and don't experience side sway. So in a later video, we're going to talk a little bit more in detail about that. But regardless, we do have the following piece of information here. So induced member moments will need to be amplified due to secondary moments. So what does that mean? What does it mean whenever we have what's called secondary moments? So when an axial load is supported by a member, lateral deformations will occur, which leads to buckling. So if you remember from some previous knowledge of buckling, let's say that we have an axially loaded member in compression here, as P increases, you start getting this lateral deformation, okay? So this thing starts to bow out or buckle. So we call this deformation, we call it little delta, okay? So this is what we call the Pdelta effect, okay? This is called P little delta effect. Okay, now this occurs in members of braced frames. So you have a frame system that's braced against side sway, okay? And so again, what happens is you have this axial compressive load that causes this buckling mode to occur, and when this member bows out and creates this deformation little delta, what can happen is you then generate a moment arm, right? You have this little moment here that's generated by P little delta, because now your line of action of P is at some distance away, little delta, from where the member is now, okay? And so to account for this is where we use this method called an amplification method, and that's where we mentioned it in a few minutes ago. We have to create an amplification factor to account for this. And again, this P delta effect, and specifically P little delta effect, occurs in members of braced frames. Now, if you have an unbraced system, then you're going to have the following happen. So for unbraced members / systems, we also have what's called P capital delta effects. And so, for example, if you have a member like this, or a system that can be represented by one support, and then you have a load here P, well, this thing is going to tend to deform like this, and you have this capital delta here, which of course generates an additional moment. Okay, so we call these P capital delta effects. Okay, so the first thing we need to do before we really dig into more details in this realm is be able to recognize when a frame is braced versus unbraced. Okay, we need to be able to look at a figure or a diagram and say that's a braced frame, or that's an unbraced frame, or this frame is going to experience side sway, this frame is not going to experience side sway. And that's what we're going to do in our next video. So thanks for watching this.